You know gravity. You drop something, it falls. Apple falls from a tree. Newton gets an idea. It's the most obvious force in the universe, so common, so everyday, that we rarely stop to consider its true profundity. We use it to pour coffee, to sit down, to simply exist on the surface of this planet without floating off into the void. But what if I told you that this familiar pull is anything but simple? What if it's boring? Relentless consistency is the very bedrock upon which the entire cosmos is built. Tonight, we're delving into the mundane marvels of the cosmos, exploring the seemingly invisible thread that binds everything together. Last time, we talked about how our very notion of time, from ancient sundials to atomic clocks, is fundamentally tied to the Earth's steady, predictable spin. A predictable spin made possible by the very force we're about to explore. So, dim the lights, maybe turn on a fan for that soft hum, and let's ease into tonight's journey together. Imagine a world without gravity. Not the sci-fi version with people gracefully leaping across rooms, but the actual, messy, chaotic reality. Your coffee wouldn't stay in the mug. The air you breathe would dissipate into space, escaping the Earth's grasp in an instant. The Earth itself wouldn't be a sphere, but a collection of dust and rock particles, each floating aimlessly, never coalescing into a habitable world. Okay? Gravity is the cosmic sculptor, the silent architect, perpetually working, binding, and shaping. It's the reason stars are round, the reason galaxies exist, the reason you have a floor to stand on. Without it, the universe would be an incomprehensible scatter of individual particles, never forming anything complex, never forming anything at all. This isn't a theoretical thought experiment for the distant future. It's the fundamental reality that defines every moment of existence, from the smallest atom to the largest galaxy. Consider your morning commute. Every step you take, every turn of the wheel, every breath of air is a testament to gravity. It keeps your car tires on the asphalt, providing the necessary friction for movement. It holds the buildings upright, preventing them from crumbling into formless piles of material. It ensures the very air pressure you need to inhale, keeping our atmosphere from simply bleeding away into the vacuum of space. It's not a dramatic explosion or a dazzling light show. Persistent pressure on your feet as you walk, the subtle resistance when you lift your arm against its pull. This is the boring, beautiful truth of gravity. It's everywhere, it's always, without fanfare, ensuring the basic functionality of your entire world, and indeed, the entire universe. It's the constant, unwavering background hum of reality. Think about a cup of water. It sits still, contained. Why? Gravity pulls it downwards, holding it in the cup. This simple act, repeated countless times a day, pouring a glass of water, watching rainfall, even the flow of blood through your veins, is a miniature demonstration of cosmic forces at play. Without gravity, that water would disperse, a fine mist of molecules drifting aimlessly. There would be no oceans, no rivers, no rain. It's the invisible hand that keeps our liquids liquid, our solids solid, and our gases contained. This seemingly trivial detail is crucial for life as we know it. The very concept of down is a gravitational one, and without it, our spatial understanding, its very sense of place, would be completely foreign. Now, let's zoom out a bit. Look at the moon. It orbits the Earth, never drifting away, never crashing into us. Why? Gravity. Its gravitational embrace is what keeps our loyal companion in its predictable path. It's influencing our tides and stabilizing our planet's wobble. The Earth, in turn, orbits the Sun. Why? Gravity. Our entire solar system is a grand ballet, with each planet, dwarf planet, an asteroid performing its precise steps, all choreographed by the Sun's immense gravitational pull. This intricate celestial dance, so predictable it allows us to plan lunar landings and predict eclipses years in advance, is all orchestrated by gravity. It's not a sudden, dramatic event, but an eternal, silent waltz, billions of years in the making, all thanks to the steady, unyielding pull. Every planet, every asteroid, every cometary ice ball is perpetually falling around its gravitational anchor, a cosmic spiral that has played out for eons. The tides, those rhythmic rises and falls of the ocean, are another boring yet profound example. They're caused primarily by the gravitational pull of the moon and, to a lesser extent, the sun. As the Earth rotates, different parts of the ocean experience the moon's gravitational tug, creating bulges of water on both the side facing the moon and the opposite side. Every 6 hours or so, the ocean level changes. It's an unceasing ebb and flow that has shaped coastlines, influenced marine life, and guided human navigation for eons. It's a silent, constant demonstration of a force that spans the distance between Earth and its celestial companions. A truly global phenomenon, driven by an invisible thread. It influences everything from marine ecosystems to the very rotation of the Earth itself, ever so slightly slowing it down over vast stretches of time. Even in the most extreme environments, gravity remains the constant, the defining characteristic. Black holes, those enigmatic cosmic devourers, are defined by their overwhelming gravitational pull, so strong that not even light can escape their grasp. They are the ultimate, terrifying embodiment of gravity's power. But even their existence, their formation, their stability, is a testament to the predictable, mathematical nature of this force. They don't just randomly appear and disappear. They are the logical, albeit extreme, conclusion of gravitational collapse. It's the inevitable endpoint for massive stars when their internal fusion engines can no longer resist the crushing force of their own gravity. Their very existence proves the unwavering rules of this fundamental force. Even when those rules lead to something so utterly alien and powerful. And it's not just about what gravity does, but what it is. Albert Einstein's theory of general relativity didn't just describe gravity as a force, it redefined it as the curvature of spacetime itself. Imagine a bowling ball on a stretched rubber sheet. The ball creates a dip, and if you roll marbles nearby, they'll curve towards the bowling ball. The bowling ball isn't pulling the marbles, it's curving the sheet that the marbles are rolling on. Similarly, massive objects, like planets and stars, curve the fabric of spacetime around them, so what we perceive as gravity is simply objects following the curves in this cosmic sheet. This isn't some abstract, theoretical concept confined to textbooks. This subtle warping of spacetime is responsible for the bending of light around massive galaxies, a phenomenon called gravitational lensing, which allows us to see distant objects that would otherwise be hidden. It's a testament to the quiet, subtle elegance of gravity, that its most profound manifestation is not a pull, but a bend in the very structure of the universe. This bending, this subtle distortion, is the reason light from distant stars appears in slightly different positions. The reason our GPS systems on Earth need constant gravitational corrections to be accurate. It's the boring, precise mathematics of the universe playing out every second. So, the next time you drop your keys, or feel the weight of your own body, or witness the predictable ebb and flow of the tides, take a moment, acknowledge the boring, omnipresent force that makes it all possible. It's not flashy, it doesn't make headlines, but without it, none of us would be here. None of our planets would exist. And our universe would be an unrecognizable, formless void. It is the quiet, reliable engine of the cosmos, the constant hum in the background that allows everything else to happen. It's the force that prevents chaos and ensures order. It's a quiet hero of the universe that makes all the exciting, dynamic, astronomical events even possible. Next time, we'll delve into another, understated, cosmic marvel, the consistent, captivating phases of our silent celestial companion, the moon. It's a phenomenon so familiar, yet so profoundly shaped by the very gravitational dance we've discussed today.